So our next concept is lightning arrestor. What is the need of lightning arrestor first? See here, generally during rainy seasons, we have thunderstrokes. Those are natural threats. Is it? Due to thunderstrokes, what happens is lakhs of voltage discharged into the earth. But in between them, more electrical equipments are operated. That's why when that much of voltage can be strikes on our electrical equipment, they get damaged. Because of that, lightning surges means they are having more magnitude of voltage and currents. Means lightning means lakhs of voltage. Whenever that voltage is applied to the conducting equipment, lot amount of current, more amount of current goes to that equipment. Then what happens? They can burn out. That's why here a device is required to reduce the steepness of that surges. That means to reduce the magnitude of surge voltages and surge currents, a special devices are required to protect our substations and electrical equipments in our house buildings. That means large buildings, hospitals, theaters, large constructions are having these lightning arresters. So to protect those buildings, those constructions against the surges. So what type of devices are used means lightning arresters, or which are also called as surge diverters. So what is a lightning arrestor? A device which is used for the protection of the equipment at the substation against traveling wave. Such a type of device is called lightning arrestor or surge diverter. So here against traveling waves means due to lightning strokes or thunderstrokes, the voltage, the produced voltage, lakhs of voltage can be traveled in the form of waves. That's why it is called as a traveling waves, whose amplitude value is very high, either voltage or current, whenever that voltage is applied to any conductive material. Is it? So that's why, in other words, lightning arrestor simply diverts the abnormal high voltage to the ground without affecting the continuity of simply here lightning arrestor diverts the path of thunderstroke to the ground here. Is it? That means that's why these lightning arresters protect the equipments or substation equipment against the lightning. It is connected between line and earth, that is in parallel with the equipment to be protected at the substation. So see here, the following are the damages caused by the traveling wave on the substation equipment. What type of damages are occur when lightning is exist, thunderstrokes are exist? Means the high peak or crest voltage, crest voltage means amplitude value. High magnitude of surge may cause a flash over in the internal winding, thereby spoil the winding insulation. Flash over can be exist due to lightning voltage. The steep wave fronts means high magnitudes of voltages. Is it? Steep wave fronts of surges may cause external flashover between terminals of the transformer. This is second type of damage. Next, third one is the highest peak voltage of the surge may cause external flashover between terminals of the electrical equipment, which may result in damage to the insulator. That means that lightning voltage can damage the internal windings of transformer, and which can also damage the terminals of transformer, finally which can also damage the insulators. That's why to avoid all these problems, lightning arresters or surge diverters are used. And working of lightning arrestor, how it can work means when traveling wave reaches the arrestor, then it provides the path of low impedance only. When the traveling surge reaches the surge diverter, it can provide low impedance. That means here the lightning arrestor having non-linear resistance. Non-linear resistance means when the magnitude of surge increases, which can provide low impedance. Is it? When magnitude increases, its impedance can be reduced. That's why lightning arrestor is a non-linear resistor. The insulation of the equipment can be protected. The shape of the voltage and current and the diverter terminal is similar to the shape of shown in the figure. What is that figure? You see here. Actually, when spark over is exist, when lightning or thunderstorms are exist, what happens here means the voltage can be raised like this. Within a shorter duration of time, this is the peak value. Is it? Such voltage in the options of protective device. But when protective device is used, what happens? Which can be decreased like this. Which can be decreased. If such voltage does not used within this time period, this is the magnitude. If such diverter is used, that magnitude is like this. That means the steepness or magnitudes of such voltage and currents are reduced by using lightning arresters, hence protected. And coming to the current also, before protecting device is used, what happens? This is the magnitude. When a protecting device is used, that magnitude can be reduced, current magnitude. Is it? That's why this is the basic advantage of such arresters. Simply they can reduce the steepness or magnitude of such voltages. That's why the equipment get protected. So after reduction of that, they can easily discharge it through the earth by diverting its path. Is it? That is the thing actually. Then what are the main characteristics which has the ideal lightning resistors? Means first, it should not draw any current during normal operating conditions. Is that right? That's it. Any transient abnormal voltage above the breakdown value is exist, quickly it may provide a conducting path to grounds. Is that right? These are the basic characteristics for any lightning arresters which they are required, which can be used as a protection against lightning strokes. Is that right? The next concept is substation grounding. What is meant by substation grounding? What is meant by grounding or earthing? Means simply grounding is a arrangement to provide a path for excessive current in the system. Is it? That path is through into the ground. That path is into the ground through neutral wire. So that means the substation grounding system is an essential part of every electrical system. The proper grounding of substation is essential and very important for the following two reasons. The first one is it provides a means of dissipating electric current into the earth during fault condition. Fault means excessive current. The current magnitude can be increased beyond the normal operating levels. Normal operating current. That's why such current must be avoided. That means such current must be grounded. Those are dissipated into the earth. Is that right? That phenomenon is called grounding without exceeding the operating limits of the equipment. Second, it provides the safe environment to protect the person in the vicinity of grounded facilities from the dangers of electrical shock under fault conditions. So substation also requiring proper earthing condition because of which can install, which has so many of equipments and they are carrying currents. If any unequal currents are exist, what happens? The magnitude unequal currents are exist in the phases means greater magnitudes of currents are exist in the system. Is it? Then what happened here? That excess currents came out from the from the operating conductors or operating system. then the current is affected by us, then shock get affected. That's why we avoid that system. Proper earthing is required for substation and any type of electrical system. So the grounding system includes all of the interconnected grounding facilities in the substation area, including the ground grid, overhead ground wires, ground neutral conductors, underground cables, foundations, deep well, etc. Ground grid means it is earth match. Earth match. A substation with a relatively low ground resistance might be dangerous. Might be dangerous. While another substation with very high ground resistance might be safe or could be made safe by careful design. Is that right? This is about the grounding of substation. By using these careful design techniques, we will ground the substation. Thank you.